Welcome back to Learn Along with Maitri. In our previous video, we learned about overfitting and underfitting. But why do these problems happen? The answer lies in a very important machine learning concept called bias-variance trade-off. By the end of this video, you will understand bias, variance, and how to find perfect balance between them. So let's begin. The goal of machine learning is very simple. We want models that make accurate predictions on new data. A model should learn useful patterns without becoming too simple or too complex. If a model cannot generalize well, its prediction becomes unreliable. This is where bias and variance come into the picture. They help us understand why some model performs well and some fail. So let's start with bias. Bias measures how much a model oversimplifies the problem. A high bias model makes too many assumptions and fails to learn important patterns. As a result, it performs poorly even on training data. Think of a student who studies only the basic concepts and ignores the detail. They may understand the topic partially, but they won't score very well in the exam. This is called high bias. High bias. Imagine two students preparing for an exam. The first student only reads, summarizes, and skips the important chapters. They don't spend enough time understanding the subject deeply. When the exam arrives, they struggle with many questions. Similarly, a high bias model learns too little from the data and cannot make accurate predictions. This often leads to underfitting. Now let's understand what is variance. Variance is a measure how sensitive a model is to training data. A high variance model learns very small detail, including noise and random patterns. It performs extremely well on training data and struggles with new data. Think of a student who memorizes every answer from practice test without understanding the concept. If the exam question change slightly, they get confused. This is called high variance. Imagine a student memorizes hundreds of previous year exam questions. They know every answer perfectly, but when a new question appears, they don't know how to solve it. The student memorized instead of learning. Machine learning model can make the same mistake. When they memorize the training data, they become too dependent on it and fail to generalize. This often leads to overfitting. So, what do we do now? We want a model with low bias and low variance. A balanced model learns meaningful patterns without memorizing the noise. This is often called the sweet spot. Such models perform well on both training data and unseen test data. Finding the balance is one of the most important goals in the machine learning. Let's connect everything together. High bias leads to underfitting. The model is too simple and fails to learn enough. High variance leads to overfitting. The model becomes too complex and memorizes the training data. A balance between model sits between these two extremes. This is called the bias variance trade-off. There are several ways to improve model performance. To reduce bias, use a more powerful model, add useful features to it, train for a longer period of time. To reduce variance, collect more data, use regularization, apply cross validation. Simplify the model if necessary. The key is finding the right balance between simplicity and complexity. So let's quickly recap. High bias means the model is too simple. High variance means the model is too complex. High bias often causes underfitting. High variance often causes overfitting. The best model balances both. This is called bias variance trade-off. Thank you for watching. If you found this video helpful, like the video, subscribe to learn along with Maitri. Comment below if you would like more machine learning tutorials. In the next video, we will learn about evaluation metrics, accuracy, precision, recall, and F1 score. See you in the next video. Bye bye.